Very good morning to all members gathered here. Today we are in the next session, Design of Welded Joints, session number 4. So we will have the basic introduction about what do you mean by a welded joint and what are the various design parameters to be considered for a successful and sustainable welded joint design, and a few basic elementary problems in welded joint design. So this and all we are going to plan sequentially in this present session. So what do you mean by a welded joint design? A welded joint design is nothing but joining of two metal plates through fusion, either using filler material or without using filler material, by considering the various design factors like plate dimensions, applied load, and permissible stresses. So these are the three major important factors to be considered for a successful weld joint design. The following next information. The key aspects of weld joint design involve proper joint design, selecting appropriate material, and fixing the optimal weld parameters like a current, voltage, etc., to perform the welding operation in a more safe environment, and implementing the post-weld heat treatments. After performing the welding operation, we have to remove the internal stress by using stress relief heat treatment process. So in order to improve the durability of the welded joint. Now we will go to the key consideration in weld joint design. The first one is selecting the right type of welded joints according to the practical application and additional required strength. Next one, material selection. So choose the right material that can able to withstand the welding condition and service loads. Then weld parameters like current, voltage, and speed for high quality weld. And post weld heat treatment, implementing stress relief aniline or the parallel subsequent heat treatment in order to mitigate the internal stresses contained inside the structure, weld structure. So this will improve the durability by doing so. What are the advantages of weld joints? Lighter weight. The weld joint structure can be more efficient compared to other joining methods. It acts as a leak-proof for boiler vessels, even tanks. We can easily modify the weld assembly according to the changing product demand and requirements. And this welding method can be more considered to be a faster process than other joining methods, can be carried out with a reduced production time. What are the factors affecting the weld strength and quality? One is joint geometry, size of the weld, defects, and loading conditions. These are the four major factors considered for a good weld strength and quality of the weld. Design consideration for specific joint types. Say butt joint. This type of weld joint is used for high penetration fusion process. Fillet weld is used to withstand the tensile and shear stress across the joint. The groove weld is normally used for proper penetration with a minor included angle across the root face of the plate. These are some of the images which has been taken from the online sources. This image illustrates about the different types of welded joints and the corresponding loading. For each type of joints, they have given the weld stress formula. This information is available in Design Handbook proposed by PhD Design data book. So from this data book, we can able to take a number of formulas according to the problem what is asked from the given information. Now we will discuss a few elementary numerical problems as given here. Consider a weld plate 60 width, 10 thickness is welded to another plate by two parallel fillet weld as shown in the physical illustration. Determine the safety load the welded joint can able to carry and the allowable shear stress across the welded material is 75 Newton per square. So these are the dimensions of the weld joint, and out of this we have to calculate what is the unknown load which is acting across the joint assembly. That is safe load P. We know that the thickness of the weld is 10 so put H is equal to 10 So we are assuming the size of the weld as equal to the thickness. H is equal to T. So H is equal to 10 Find out the area of the weld using the proposed formula which is given here. Then we know the allowable shear stress tau is equal to load by area. So from this equation we can able to find out the safe load P. We know what is the allowable shear stress and also the area value. So from this we can able to calculate the unknown load in terms of Newton. So this is a basic simple problem. Here we determine the safe load across the welded joints, unknown safe load, unknown quantity of the safe load across the weld joints for a given plate thickness, width and allowable shear stress. So now we'll see the other problem in two different methods. One by data book, you're referring the formula from the design data book. Another one using manual equations without using the data book. Consider a plate of 100 width and thickness 12.5 is to be welded to another plate by means of two parallel fillet weld. The plates are subject to a load of 50 kilonewton. Find the length of the weld so that the maximum stress does not exceed 56 Newton per square. So here in this problem, they have given the safe load 50 kilonewton tensile on both the sides and the maximum stress 56 sigma equal to 56 Newton per square, allowable stress. So we have to find out what is the length of the weld, unknown length of the weld. So let us see the solution. So the proposed problem can be solved by following two different methods. But exam point of view, the students are advised to follow method 1. However, for understanding the basic principle of stress induced in the joint, method 2 is also much essential, very useful. Now, let us see both the methods. Using the handbook, design handbook, we can able to take this formula from corresponding page number 11.3, welded joint design. For double parallel fillet welded joint design, sigma B is equal to the weld stress 0.707 into P by H into L. Using this formula, we can find out the length of the weld 50.5 We know P value, H value, and sigma value. Only L, that is the unknown quantity to be measured. The next subsequent method, alternate method, using area of the weld, so we can find out the area of the weld in terms of length, unknown length. So maximum stress formula, load by area. So the same answer we are getting, L is equal to 50.5 So in both the problems, just we have quantified the basic dimensions of the welded joint design. The previous problem we saw what is the unknown load which is acting across the structure, weld joint structure. Here, what is the length of the weld? For a given loading condition, plate thickness and width of the plate, what is the so-called length of the weld to be designed? So from this information, I conclude that in summary, the design of welded joints requires a careful consideration by taking out various factors in order to make a very strong, durable, and reliable welded joint design. Understanding the various types of joints, material properties, different welding parameters, and post-weld treatments, these are the main important thing for a successful weld design. So with this few information, once again, I thank each and every one of you. We will meet in the next lecture series from same subject, design of machine elements. So thank you once again.